Check. Hey. Yeah. Okay, so let's get started here. We're going to go with number 1. Thanks, everyone. Good afternoon. So we've got 2 plus 2/7 plus 2 out of 49 plus 2 out of, I'm going to guess it's 243. Okay. Sorry, 343. It's like I've been using this since 2014, 2015. Could be. Could, perhaps. So I think that the main guideline is if you're going to be asked what a series converges to, it's going to be one of those 4 series that we talked about. I mean, when I said that they were really important, I probably undersold it. They are incredibly important for this. 100% have to memorize them. Okay, so let's take a look at this series. If you'll notice, that's 2 times 1/7 to the 0 power plus 2 times 1/7 to the first power, 2 times 1/7 squared, 2 times 1/7, I'm just going to guess that's 1/7 cubed. I don't see how it couldn't be. And so that's a geometric series. We're going to, that doesn't look like the word series. First term is 2 the ratio, that's equal to 1/7. So basically the sum is 2 multiplied by 1/7 to the n power, or n, starts at 0 and goes to infinity. And that's going to be equal to 2 over 1 minus 1/7. What does that simplify to? 6/7, so 7 over 6, 14 over 6. If I did everything correctly. That's going to be equal to 14 over 6, and this, I'm still having problems with this stylus. 14 over 6 when, I'm going to replace the stylus and see if it makes a difference.
Okay, no, I get it. If you divide each way,
Yeah. Can't hear you. It sounded like you said, how do you know it's a cyber train? By definition, if it doesn't converge, it diverges.
If the sum isn't a real number, then it dies. So if the bottom equals 0,
it's so bad. Look how it's like going in that direction. Oh no, it converges.
Okay, so I cannot find another stylus.
she's pretty.
Try this one more time. Okay. What do we get? Okay, converges if, what just happened? If the absolute value of the ratio is less than 1. Okay, So is that absolute value of the ratio less than 1?
Yes.
Yes, it is. So it converges.
You have to write that. That's over 6, right?
So converges.
Just the first question.
Converges. Good.
Starting
Yeah.
off strong.
So, you know, you use first term ratio.
Mhm.
Is it okay to like go about it as like what it's written in the book as a over 1 minus
R. A 1 minus.
r, which
Uh-huh.
is like the thing that's inside of it. It's like, it's basically like the same thing, but I'm just wondering which one you want us to.
It doesn't matter.
Okay.
Let's skip over 6.
All right, let's take a look at. We did 2 in both classes, right?
Yeah, I think so.
Should we do it again or no?
No, that's great.
No. Okay. So let's take a look at 3 then. Brandon, do you have a question or?
I think I know it. It's like, well, no, it doesn't matter. It's not going to be an FR. It's not going to be an FRT. So.
Okay. All right. So let's go to 3. We've got find the values for x for which this series converges. The series looks like this: 3x plus 1 to the nth power. And you know, you kind of really quickly see whether or not one of these will be a geometric series. I'm looking at this and I'm saying, yeah, that looks like a geometric series to me, for a couple of reasons. But if you don't see it right away, you know, like I said in class, just write out the series. When n equals 0, you get a 1. When n equals 1, you get a 3x plus 1. When n equals 2, you get 3x plus 1 squared, 3x plus 1 cubed, etc., etc. So that means that the series is geometric with first term is 1, ratio is, well, we keep multiplying by 3x plus 1, so that's my ratio. So putting it all together, the series 3x plus 1 to the nth power converges to 1 over 1 minus 3x plus 1. It looks like I can just leave it like that because I don't see a fraction inside of a fraction. Okay. If and only if the absolute value of 3x plus 1 is less than 1. Again, the ratio has to be less than 1. Right, this is not in one of the form that I want it in, because what I want to see, what I want is the absolute value of 1 times x minus the center is less than the radius. Okay. And that's not what I have here. I've got 3x, not 1x. So I'm going to multiply by 1/3 or divide by 3, depending on which math teacher you had. Doesn't matter. You all should be smart enough to figure that out. So that gives me x plus 1/3 is less than 1/3. So now you can just kind of read that. The center is negative 1/3. It's negative 1/3. The ratio, sorry, not the ratio, the radius, that's equal to 1/3. So it looks like this is going to converge for x. And I saw some really weird looking epsilons. Maybe it was because it was a stats test. But you do want to make an actual epsilon and not like a capital letter E. That's not exactly what it is. Alright, so we got negative 1/3 minus 1/3 is negative 2/3. Negative 1/3 plus 1/3 is 0. Yeah. So that's the interval of convergence.
Would you ever give us one that's not geometric
Yes,
for converging?
next week.
Oh.
Right, you asked us
Yes, I remember, and then I forgot.
Next week. Next week.
I'm very excited about it. Just can't wait.
Yeah, it's better if we don't talk about next week yet.
Like you're preparing us for war. Like you're getting the easy stuff out of the way. So that
We are.
this is not going to be pretty. I can already feel it.
Yes, you can.
Question 4. Find the function represented by summation. And this is basically the same problem again, by the way. Okay. Oh, no, that's an n, my bad. Okay, so that series is 1 plus x plus 2. That doesn't look like a 2. Plus x plus 2 squared plus x plus 2 cubed and dot, dot, dot. Okay, so that's good. That definitely looks like a geometric series to me. This is going to converge, first term is 1. The ratio is x plus 2. So this is going to converge to converges to, what is that, 1 over 1 minus, put the parentheses there to avoid the algebra fail, avoid the BAM. If and only if the absolute value of x plus 2 is less than 1. Oh, this is really nice. I don't actually have to do anything here. It's already in the correct form. We have 1x minus the center. So that's center is negative 2. Radius is 1. So your interval of convergence, x, needs to be between, see, negative 2 minus 1 is negative 3. Negative 2 plus 1 is negative 1. That's 4. What's that? Yeah, right there. So the function that it converges to is this right here.
Is it okay we simplify that? So
Of course. Just make sure you do it correctly. I just don't want you to have algebra fails in your... I don't want to have to BAM all these tests because you're simplifying where you don't need to simplify. Okay, we didn't do 5 in period 4, right? So let's do... we did 5 in period 1. Okay, so we're going to... Same approach. You've got this series, negative 1 to the n. That doesn't look like an n. X minus 3 over 10 to the n power. And we can write that out. 1 minus x minus 3 over 10, parentheses to avoid the BAM. X minus 3 over 10 squared minus x minus 3 over 10 cubed, so on and so forth. Okay. This does look like a geometric series with the first term did I just write there? The first term looks like it's 1. The ratio, that looks like it's negative x minus 3 over 10. Be a little bit careful here with the algebra. That negative sign applies for the entire fraction, not just for the x. It's a common, yeah, that's what I was thinking. That might be a good thing to do.
If we carry the -1 inside the n, that would be
Yeah,
fine.
that's fine. That would be 3 minus x over 10?
Yeah.
Yeah, that's fine. That's fine. Okay, so this series, -1 to the n, x minus 3 over 10 to the n, converges to, 1 over 1 minus negative x minus 3 over 10. Which is the same thing as 1 over 10 over 10 plus x minus 3 over 10, which is the same thing as 10 over 10 plus 3, no, 10 plus x minus 3, which, I would be fine if you left it like that. I would imagine that you have way more pride, so you're probably going to make it 10 over 7 plus x. That's what I would assume you'd do. Okay, so it's going to converge to that when, and this is kind of taking the problem a little bit further, when the absolute value of negative x minus 3 over 10 is less than 1. Okay, just to do this real quickly, this is the same thing. That'll help us with our algebra fail. And so you get x minus 3 less than 10. So center is 3, radius is 10. So this will converge when x is between -7 and 13, is that right? -7 and 13. Looking good? So that's 5. Are you okay on the way out?
Huh?
Are you going to be okay on the way out?
Yes, my car's right here, so.
Wait, are you driving?
Yeah, because my injured foot is my left foot and I'm driving my right foot. Well, yeah. I get to park like next to the hand building because I have a handicap pass.
It's amazing that you get to drive.
When I injured my foot that night, like I drove myself home from town. I feel like you drive.
That's nuts.
I know.
Good luck.
Thank you.
Someone want to get the door?
I know a person who goes through like, I know a person who goes through that. Like, consistently. Oh, what's the name?
Thank you, Gloria.
Yeah, they have like one of those apps.
I think it's too fast to get breaks.
Can someone hand me that packet of taco sauce? I feel like it's going to splatter.
Like, so you're just like, no, but the movie doing every trip, so you're like, using every trip,
Okay, find the first four. Find the first 4 terms and the. No, just the first 4 non-zero terms. Very cool. All right, sine x
We're really good with that.
equals
Wait, what's the function?
X sine 2x.
well. First of all, maybe I should go along with that. X sine 2x. If you look at that, you know, the 2x part, that looks like we're going to center at 0. So we don't have to start all over with our polynomial. We can just modify our pre-existing Maclaurin polynomial. So that's the plan. Start with sine x and slowly modify. So the trick here is sine is an odd function, so I need odd powers of x. X to the first power, x cubed over 3 factorial, x to the 5 over 5 factorial, and x to the 7th over 7 factorial. All right, that looks good. Next, let's do, we want to make the sine of 2x. Oh, I forgot a couple things. We're stopping here in 4 terms, so this technically should be, now it looks like an inky mess. Right, that's good. That should be an approximation sign, because we're stopping at those first 4 terms. Okay, so sine 2x, we're just going to replace all those x's with 2x. So 2x cubed, 2x to the 5th power, 2x to the 7th power. I did it again. Wait, oops, I did it again? God, Britney Spears is like oldies for you, isn't it? Britney Spears. Childhood?
Don't disrespect my favorite
It's not my fault that I have to.
Okay. I think it might be a good idea if we simplify this now. So I am going to simplify that now. And by simplify, I mean I'm going to try to get the 2 to the 3rd power and the x to the 3rd power separately. That's going to help out, especially if there was more to this problem. There isn't more to this problem, but if there was more to the problem, it would be helpful. Remember, you don't actually have to know what 2 to the 7th power is. You can just leave it as 2 to the 7th power. No one's asking you to multiply that out. And finally, if you want x sine of 2x, you're just going to multiply every term by x. So that's 2x squared minus, and now that we've simplified this, this becomes a little bit easier for us. That's x to the 4th power, 2 to the 5th over 5 factorial, x to the 6th power, 2 to the 7th over 7 factorial, x to the 8th. So that's that. Okay. Anything else with 6? Good. Again, don't start over. Don't try to use the Taylor's theorem and Maclaurin's theorem if you don't need to. If you had all the time in the world, I'd say go ahead and do it, but you don't have all the time in the world.
That's true.
Yeah.
Just for my piece, could you do the general term?
You would like the general term. Okay. So the general term for sine x, the general term for sine x would have been negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial, right?
Yeah.
Okay. So then once we do 2x, we're going to get negative 1 to the n, 2x to the 2n plus 1 over 2n plus 1 factorial, which down over here,
You separate the two.
we separate, yeah, so negative 1 to the n, 2 to the 2n plus 1 over 2n plus 1 factorial, multiplied by x to the 2n plus 1, and then, yeah, now it turns to 2n plus 2. That n looks like a 2. 2 to the 2n plus 1, 2n plus 1 factorial, 2n plus 2.
So, Mr. Ferreira?
Yeah.
For the last general term, is there a reason why I split 2x because they have different exponents in the end? Because one of those 2n plus 1, and the other was 2n plus 2.
Yeah, that's a good reason to do it. Yeah. And it's not uncommon for these questions to involve differentiating and integrating. So if you have the 2x still in a parenthesis like it is over here, I don't know if you can see it. But over here, if you have it still in a parenthesis, then you're going to have to use chain rules and u substitutions, and that's a bad idea. Okay.
I don't know. It's not that I'm still talking about it.
Okay, 8. We want a Taylor polynomial order 2 centered at 0. That just basically means a Maclaurin polynomial where the highest power is 2. Did I skip 7? Oh.
I mean, you don't have to. I think we need 7.
Six, 7.
7, Taylor
Actually,
Yeah.
7 is pretty.
Taylor polynomial order 3 generated by f of x equals cosine, centered at pi over 3. Oh, bummer. Centered at pi over 3. We're not centered at 0 anymore. Not centered at x equals 0. Must do the whole process.
Right process and big letters.
In this game, what
There you go. just to emphasize how annoying.
The whole Taylor process. Okay, so we start off with f of x. That's equal to cosine x, which means f of pi over 3 is, oh gosh, is that 1/2? It is.
Order 3 is 4 derivatives.
Order 3 means the highest power is 3.
Yeah, so 4 derivatives.
3 derivatives.
Oh,
3
right.
derivatives. F prime, negative sine x. So f prime of pi over 3 is negative root 3 over 2. Oh boy, this is already looking like a pain. F double prime, That's going to be negative cosine of x. So f double prime of pi over 3 is negative 1/2. F triple prime of x is going to be equal to, well, I'll be darned, it's back at sine x. So f triple prime of pi over 3 is rad 3 over 2. What happened? Rad 3 over 2. Okay. Let's put together Taylor's formula. We have cosine of x can be approximated by f of pi over 3 plus f prime pi over 3 x minus pi over 3 plus f double prime of pi over 3 over 2 factorial x minus pi over 3 squared plus f triple prime pi over 3 over 3 factorial x minus pi over 3 cube. Ooh, aren't we so lucky? Cosine of x, therefore, what was the first? What was 1/2? Thanks. Negative rad 3 over 2. Negative rad 3 over 2 x minus pi over 3. I'm going to keep these in parentheses. Plus, that's going to be 1/2. And is this one negative 1/2 now? And this is x minus pi over 3 squared. And what's next? Positive rad 3 over 2? Yeah. 1 over 6 root 3 over 2 x minus pi over 3 cubed. Actually, it looks like you can leave it like that. I don't see a problem with it. Yeah, just leave it. That's good enough for me. No need to multiply out fractions. I've already gone and made sure that there's no fraction compounds. So you're good. Questions on 7? I feel anxiety leaving it like that, by the way. A lot of anxiety. I would expect you have a lot of anxiety too. Okay, 8.
Adding negatives.
Huh?
Adding negatives
Adding negatives.
instead of just subtracting.
Seeing 1/2 times 1/2, that kind of gives me a little bit of...
Oh, yeah. That is pretty.
But it's better for you. I'd rather you do that than, mess that up. Taylor polynomial centered 2, order 2 centered at 0. Yes. Centered at 0. That means use the memorized series. Okay. So we need the series for cosine. Cosine x is equal to, cosine is an even function, so I'm only looking for even powers. So to the 0 power is 1 squared is x squared over 2. Oh, and that's it, right? Order 2. Cool. Stop there. Cosine of 0.2. That's going to be 1 minus a half of 0.2 squared, which is 1 minus 1/2 of 0.04, is that right? Which equals 1 minus 0.02 cosine of 0.2 is approximately equal to 0.98. I like that problem. That was fun.
What?
It was what? Chalk? Chaw? Chop?
That's like, it's like C-H-O-P.
Chop.
It just means like easy. Like,
What was that from Mean Girls? The sharp what was that? What was that word? What was that word? Fetch. Fetch. You're trying to make fetch happen. Is that what's happening here? Hayden's making fetch happen. Do we need to do 9? Did we do 9?
no, can we do 9?
We didn't.
Can we do 10 first?
Well, we're leaving at the same time.
It's like we did 9 days ago.
Not in class.
We did that in class.
Yeah, did we?
Yeah.
Alright, my
Yes,
bad.
he did.
Oh, let's do number 10 then.
Okay.
And then, maybe if they want to sleep, we go to 9 too.
Okay. Yeah, you're kind of at her mercy on this one. Okay, so find the series for f of x equals cosine of negative 2x. The hell is this question? Maclaurin series, okay.
In sigma notation.
What's sigma notation?
Sigma notation has a sigma.
Really?
Okay. Alrighty then, let's start off with cosine of x. Cosine of x is 1 minus x squared over 2 plus x4 over 4 factorial minus x to the 6 over 6 factorial plus, and this is the part that you have to have memorized, negative 1 to the n, x to the 2n, 2n factorial. If you want to do cosine of negative 2x, 1 minus negative 2x squared top of 2, negative 2x to the 4th top of 4 factorial, negative 2x to the 6th and 6 factorial, negative 1, negative 2x to the 2n factorial. Okay, now all of this business here doesn't really matter because we're going to be writing this in sigma notation. Doesn't matter. Because, not BS, that's something else. Because sigma notation. So this is the only one we need to simplify.
I think you're missing an n. Negative 1 to the n.
If I'm missing the n here, right? You know what I like about this is, like, when you see this over here with a negative 2x, you kind of, how do I say this? you can kind of see why the cosine of negative 2x is equivalent to the cosine of positive 2x.
Oh. Because it all cancels out.
Yeah, the negative squares out.
Pretty cool.
And I'm wondering if they're calling this an even function because of the powers, or if it's just something that happened and it was a happy coincidence. I'm not sure. But okay, so we'll finish that then. It's a sigma of negative 1 to the n. That's negative 2 to the 2n. 2n factorial to the next to the 2n. You could simplify that just a little bit because negative 2 to the 2n is the same thing as positive 2 to the 2n. So n goes from 0 to infinity. Negative 1 to the n, 2 to the 2n, or 4 to the n, 2n factorial, the next of the 2n. That's my sigma notation on that one. Bye-bye.
Just thank you.
Good day.
Are 11 the only ones that would pop up with that FRQ?
Those are the ones that are intended specifically for FRQ. I mean, there could be more stuff added to it. Were we supposed? Did we want to go back to 9 or no? Can we do 9? Okay, we're gonna do that number 9 for Brittany. Okay, so for 9, we have order 3, right? So order 3 means third degree. Highest power should be 3. Get as close to the third power as we can. Which series should we use? Well, of course, we should use the series for x, for e to the x. So you're supposed to have that memorized. It's 1 plus x plus 1/2 x squared plus 1/6 x cubed. Have a good day. So that's, this is approximately equal to, because we're stopping here, this is the third ordered polynomial. Stopping right there, third order polynomial. So now we just got to substitute 0.4. So e to the 0.4, that's going to be, have a good day, 1 plus 0.4 plus 1/2 of 0.4 squared plus 1/6 of 0.4 to the third power. Now, you're going to have to do some quick math. That's 1 plus 0.4. 0.4 squared is 0.16. Half of 0.16 is 0.08. This is 0.064. Now if I divide this by 6, I get 0.010. 36 times 6, right? It's 36. So e to the 0.4 is about 1.4906.
was laughing the whole time because Henry kept laughing. And his laugh's really funny, so then I keep laughing, but then he keeps laughing because I'm laughing. And
It's a
I
laughatorium.
want to see the answer, but I keep laughing, so I can't look at
4906. Yeah, that's it. That's it. Yeah. Absolutely. We did 2/5 in period 4.
Yeah, no, that's 5 something.
5:30. No, 4:30.
Oh, that's early.
I'm so glad I have a clock back there now.
How long has this been broken for?
Which
This
the clock?
Yeah, the clock.
They just royally messed it up this year. It used to be the minute hand was okay, and the hour hand was off, but that was fine because I could read the minute hand.
Yeah, I never noticed the whole thing.
Yeah.
And then I just, like, 2 weeks ago. Are you feeling better, Henry?
Yes.
Oh, thanks.
Okay.
Because you said quick maths, by the way.
Quick maths.